Hi people, how are you? I'm glad to see you here. As you know, our workshops about intelligent machinery and AI architectures, we are happy to see you here. And we all know AI is future and it's our future. So in this workshop, we want to give you a short introduction about AI, and after that, a path to AI, and give you the problems with architectures of machines and so on. We are happy to have Mr. Muiz Alvi. He's General Secretary of MLSA Islamabad. He talks about AI, and I will talk about intelligent architectures for intelligent machine. So we will go to Mr. Muiz Alvi to talk about his session. Mr. Muiz, are you with us?
Yes, thank you so much for the introduction, Huzayfa, and I'll take it from here. Let me just share my screen. And Assalamu alaikum, everyone. It's really nice to see you guys here. Okay, let's start. All right, so I really hope that it's visible. Let's just start here. Okay, so this event, as the introduction was given by Huzaifa, it's about artificial intelligence. And what we're going to do is that I'm going to cover the introductory part, and Huzaifa, he's going to talk about the more of the one of the practical applications, a very doable application, which is making your computer architectures more intelligent. So without further ado, this is me. I'm Muiz Alvi. I'm a beta Microsoft Learn Student Ambassador. I am the General Secretary of Microsoft Learn Student Ambassadors Islamabad, which is the most active chapter of the city, and as Uzef has also told. And I am the Vice President for ACMS Student Chapter, which is the biggest computing society on our campus in NUST Edgetol, Pakistan. I'm also the co-director of Startup Grind NUST, which is aimed to empower startups. And I am an AI and ML enthusiast. Okay, so moving on. This session is about artificial intelligence, its introduction, the components of AI, and the applications of AI. So what I plan to do is I plan to give you the guide on what it is actually. I would like to talk about the applications, like how it's being used, and I would also like to talk about the components, that is the part of AI, and what exactly differentiates these components. Like you may have heard of terms like machine learning, you may have heard of terms like deep learning, but what exactly differentiates them? So I'm going to talk about that too. Small disclaimer, this is an introductory AI session. We will not be talking about the math intensive or programming intensive elements of this field. I'm sure a lot of you who are currently doing courses already know that there's a lot of math involved and there's a lot of programming involved, but we're not going to be covering all of that here. We're just going to give you an insight on what AI is and how we're going to provide you with resources and how you can make use of them for your learning. So this is an important thing to note here. And we can't really go over all of that right now. Like it's going to take, if you even started with the courses, it's not possible in a 1-hour session, and it's not even possible in like for a month or something. There are like 5 to 6 courses of deep learning itself. So it's not possible to get it all done here. Okay. The objectives here is to understand the applications of the field of AI, understand and differentiate AI components, discuss the learning paths and resources that you can take. And also there's an additional topic here that we're going to discuss, and that is making use of cloud technologies in AI. So we know that AI is the future, but the future of AI is actually cloud technologies. So what is artificial intelligence anyways? A basic definition of artificial intelligence is that you make use of computers to solve problems or make automated decisions for tasks that, when done by humans, typically requires intelligence. So what differentiates AI from simple programs is that you actually need a thought process to get those objectives done. For example, shape detection. Like if you look on the right side of your screen, you can see three shapes, and you can actually identify them. That one of them is a circle, one of them is a triangle, one of them is a rectangle. And if you give this to like a 3-year-old or a 4-year-old, a toddler can actually identify this, toddler and up. But what cannot identify this is like animals. If you give them these shapes, they won't be able to tell you what shapes they are because they don't have intelligence. They do have intelligence to an extent, but not enough for us to categorize that as intelligence. So any program that can do these kind of tasks, you actually say that that is in AI, basically. That's using an AI. You can have speech detection, shape detection, all of that. We'll go more on that in the next slides. So the power and uses of AI, like how powerful is AI, basically? Now, you can see that we have this figure on the right side of the screen, and I'm gonna check the comment section right now, and I want to know that how many of you can identify who this being is. Okay, so I'm just gonna do that. It's gonna take me a minute. Please tell me in the comment section who this being is. What's the name of this being? Okay, here we go. All right, so no comments so far. Does anyone here know what the name of this being is? I would really like to see a comment on that. Okay. I think that I am having some error. I can't see the like Q&A. Maybe it's fine. It's totally fine. So continuing on this, yeah. Okay. So basically, 1 second, please. So basically, the power and uses of AI. Okay, so this robot is actually called Sophia, and she is an AI robot that makes use of artificial intelligence. And I'm going to show you a small video clip about that if you don't know. I'm assuming that no one here knows about it because we got no comments, or I don't know, I can't see them, or what's the issue. This is a small video. Let me just share computer audio with you guys. Okay, we got them. We got comments. It's Sophia, AI enabled Sophia. Correct. This is Sophia. It's really nice to see that we got comments. I was beginning to get a little bit worried. So what I'm going to do now is I'm going to play a small video over here for you guys, and really hope that you get the audio. So if you don't get the audio part, can a moderator please text me if they don't get the audio? Okay, so enough about that. I really hope it didn't creep anyone out. So the thing is that this is an AI, it's a robot actually, it's an artificial intelligence being that can actually communicate with you, can actually have a conversation with you, can actually hold up a conversation with you. So this thing is kind of important. This is like a very interesting field of robotics where work is being done. The reason I showed you this is that I want to clarify a common misunderstanding that we have. And that misunderstanding is basically that when people think of AI, they automatically think we're talking about robots, which is not actually true. This humanoid is actually, regardless of its robotic structure, it's actually using an AI interface, an AI, you could say database, or an AI that actually tells her that if you get this question, then you take the elements of this question and you answer it in a certain way. So this robot is actually making use of artificial intelligence. It is not exactly an it's not an artificial intelligence as a whole. So we're not looking at beings that have abstract thought. Abstract thought is the kind of thought that we have, like human beings, that we're staring at a wall and we're thinking about things. We don't have AI that can actually do that. AIs are they make use of certain techniques to process data. If this is confusing, that's fine. I'm just going to move on with this, and we can look at it more when we talk later. So the power of AI. First of all, we have data processing and cleaning. So data processing and cleaning is that a lot of companies, a lot of big companies, like you have Microsoft, you have other big companies, and not just these companies, like you have other companies that make use of customer data. They make use of tens of thousands of customers' data on a daily basis. Now, those data have like errors. Like for instance, some of us, we spell our names wrong. Some of us don't give the correct information. So what happened before, like if you have like 10 names, a list of 10 names, then that can easily be fixed. Okay, like for instance, if my name is Muiz, M-U-I-Z, and I spell it with a small m, capital U-I-N-Z, which is the wrong format, then you can have a person to manually look at it and fix it. But the problem is when you have tens of thousands of okay, no audio. Am I audible? Can you guys hear me? Like, can a moderator please text me if I'm not audible? Okay, I'm audible. So I think that for the Sophia video, you couldn't get my computer's sound. That's fine. I'm actually going to share the video with you guys. You can check it out later. Like it's going to be in the resources. But so I shouldn't be playing videos right now. That's fine. Okay, so moving on. When you have tens of thousands of data, you can't make one person fix them because it's obviously going to have a lot of errors. So you would want to make use of software that can over time recognize certain patterns, certain mistakes which are done. Like you can tell the AI to keep the first letter of the name capital and the second, third, so on should be small. So you can actually make AI do that. So data processing and cleaning is a big field of AI, and a lot of companies make use of it. Then you have speech recognition. Speech recognition is basically like, for instance, I'm talking right now, and you guys, you can actually understand what I'm saying. Like I asked you the question, what is the name of this humanoid? And you guys saw the question, you heard the question, and you made sense out of it, and you actually wrote an answer that this is Sophia, this is a robot. So when you did that, that's basically speech recognition. And the field of AI is also making use of that. Like you have Siri, you have Google Assistant, you have these kind of technologies where you can just speak into and they actually understand you. So this is speech recognition. This is also a very vast field of AI, and this is being used everywhere. You have it in healthcare, you have it in, especially in security systems for your home. So that's that too. Then you have natural language processing. So natural language processing is the way I'm talking right now. Like for instance, if I say the famous phrase, this is actually the one I used in a blog too. So anyone who's read the blog is going to be like, he's just repeating stuff from there. But okay, anyways, I'm just going to use this one because it's coming to my mind. Man is to woman like king is to blank dash. So what do you think is the best fit for this sentence? Man is to woman what king is to blank. Can you guys try to fill the blank in the comment section to make this look like an appropriate analogy? Do that. I will check the comments again. Have Saudi citizenship. Yes, she does have Saudi citizenship. Sophia, an AI-based human being. Yes, thank you, Sophie. Sophia also have Saudi. Yes, she does have Saudi citizenship. No audio. I'm sorry. I will share the link after this. Sophia, yes. Okay, so man is to woman what king is to blank. Fill in the blank. What should be inside the blank? Come on, guys. This is really, really easy. I'll actually publish this question. Wait, I have the option to publish. Man is to woman what king is to blank. So any answers so far? Let's see. Queen, perfect. We have an answer, and it's Queen. I'm sure that a lot of other people have also guessed this. So you know, for some reason, you just thought about it, that man is to woman, what king is to dash, and you filled it with Queen because it makes a perfect analogy. It makes sense, this statement. So this is the field of natural language processing, basically, that you take, you study the context, you study your AI, basically, it studies contexts and it studies different patterns and it tries to make sense of that. And you have mobile phone applications, you have predictive keyboards, you have other such stuff. These are all applications of natural language processing, and there's a lot of work being done on NLP. And natural language processing, the short form is NLP. There's a lot of work being done there. Image processing and transformation. So this is basically that you take an image and you try to make use of a filter or something of that sort to make the image transform and make the image look more better. Now, a lot of people have made use of there was this famous artist who was known as Mr. Van Gogh. What they did is they took Van Gogh's Starry Night, which is a very famous portrait of his, a very famous picture painting of his, and they convoluted it with different objects, even with themselves, and they produced even more amazing imagery. So I'm actually going to go to Google Images and show you that for 1 second. Okay. Cool. I'm pretty sure I can find something. Yes, so what they did is, like, if you pay attention to this image over here, let me just zoom in. Okay, what they did is they had this image on their left, they convoluted it with the Starry Night, which is his image, and they produced this very amazing and pretty looking picture here. That is the field of image processing and transformation. You process images and you transform it. But this can be done through any, like, say, object-oriented programming as well. So what is the work of AI here? A lot of people may be thinking that. What AI does is AI takes out the features, extracts the features of these images, and tells you that, okay, these images are important. These features are the essence of these images, and they combine the essence together to give you an even better image. And if you train this AI over time, it will produce even better quality images for you. So that's that. Okay, moving back. So, okay, then you have computer vision. Computer vision is the field of, well, mainly a lot of people talk about this because of self-driving cars. Elon Musk is currently the #1 billionaire, as according to my knowledge. I heard that Jeff Bezos beat him again, but I think that Elon rose up again. But the thing is that he is the founder of Tesla. And what Tesla does is Tesla is releasing self-driving cars where you just have to sit inside and it drives for you. So that's something that's going on in computer vision. Computer vision is basically that you take an image, a picture of the surrounding, and you try to identify the objects in that surrounding. So for Teslas, for self-driving cars, what they do is that they scan their environment, they look for pedestrians, people walking on the road, traffic lights. They see that, okay, there's a traffic light up there, and the traffic light is green right now, so the car can move. And if it's red, they can't move. If there's a turn, it detects the turn by taking pictures or scanning the environment and making use of that accordingly. That's computer vision. Robotics, again, you have Sophia robotics, you have certain robot arms. If anyone has actually checked out Tesla, you know that Tesla is making use of a certain charger. What the charger does is when you put the car next to it, the charger lifts up and automatically plugs inside the car. So that is the use of robotics. Robot arms, other smaller nanobots can be used. So this is the field of robotics, making smarter robots that improve over time. And of course, you have automation. Everything is going towards automation, where you had like 100 people, say, that used to clean or process data. Now you have a single software that can do that. And another famous example of automation is your autopilot. It's your self-driving planes, and you even now have planes that can land themselves. So this is all automation. And we've had self-landing planes for quite a while now. This is actually also regarding AI. But even when AI wasn't that strong, even when we didn't have self-driving cars, we did come up with technology that could land planes. That is automation. So you've replaced humans completely. And it's just a matter of time before Sophia, she took citizenship in Saudi, and it's going to be a matter of time before she takes over the whole world. So We should be careful, but we should make use of this gifted technology as well. The components of AI. So how do you go about it? How do you actually create a self-driving car? How do you actually create something like this? Like, what is the way? Do you just tell an application to do something and it does that for you? Well, the answer is sort of yes, you do that, but you have to do it in code. As I said before, that this is a very math intensive and programming intensive field. So you're basically programming the mathematics here. And it's not all programming. The good news is that right now in modern day, you have certain technologies that make use of drag and drop. So you can actually create models using drag and drop too, but we'll talk about that more later at the end. So the first thing that you should do is that you should learn Python. Now, first of all, let me just clarify, there are going to be a lot of people here who know programming. There are going to be a lot of people here who don't know programming. There are going to be people here who know C, C++, Java, but don't know Python. So for all of them, I'm going to say that you should learn Python. If you're good at a language like C, C++, or Java, it's going to be easier for you to shift to Python. And the reason we're using Python here is because we want to, as mentioned, we want to make use of the many deep learning libraries available. You could go to JavaScript too, like you have certain libraries called TensorFlow.js, but you don't want to use them right now because, again, these libraries have all been created using Python, so they don't have much support outside their original framework. So I'm going to show you a few of the resources I have available for you, and I will be providing the resources at the end of this session. So our first resource is that there's this actual video over here, which is called Learn Python in 5 minutes. This is perfect for people who are starting out who have done a different language and want to learn Python, like just want to see how functions work, just want to see the syntax and the key differences. There's this video. I will provide the link for this. Okay, and then you have, for people who have just started out with programming, who don't even know what programming is, but want to get into AI, or who want to practice Python, then the best thing you can do is you can sign up on HackerRank. HackerRank is a free website where when you sign up, it gives you a lot of options. Like you have your interview preparation kit, your problem solving. You can just go here, you can select Python, and you can start solving problems. Like it's really that easy. Like you have different Python problems here. Again, this will be all given in the resources, so you can make use of that. And for the beginner level problems, I actually have like a GitHub repository here. It's called Python Problems, and it has a few of the problems of Python solved here. So you can feel free to make use of this. This is my GitHub profile. I would like the moderator to put the profile in the announcements, so you can check it out and you can make use of all of these features, these solutions to the problems. And I've also given all of the questions here too that you can practice. So for someone who is completely, no. Okay, so for someone who's completely new to this, completely just starting with this, they can make use of these problems. But someone with intermediate knowledge, one second, an error here. Okay, but someone who is a little not that new here and just wants to like get it done quickly, they can just go to these problems over here and they can make use of these solutions. Again, these are my solutions. I created them, so there's really no issue in posting them or you using them. It's completely fine. It's all open source. Okay, those of you who don't know about GitHub, GitHub is actually this amazing place. It has a lot of features with it, but for now, I'll just say that it is a place where you can upload code and you can get code from. So you have contribution, you have all of that, and I would say that people over here, they should create a GitHub profile and make use of the resources over there. That's a little important. Okay, so you have this small issue. Can I have 1 second? Wait. Okay, so anyways, you have all of this going on, and guys, just give me 1 second, please. Okay, there's no issue. Okay, so all you have to do is you have to sign up for HackerRank. You can practice Python there and you can learn it. And it's important for you to know Python because of the deep learning libraries over there. I will go over that in a minute. So again, that's it for Python. I will provide all the links to all of this in the resources. So now you have, okay, I want you to pay attention to this diagram over here on the right side of the screen. This diagram suggests that you have a field called artificial intelligence. You have a subfield of artificial intelligence, which is called machine learning. Then you have another subfield of machine learning, which is called deep learning. So I'll be going over these components in detail in a minute. And this is actually the learning path that you should take if you want to develop stuff like self-driving cars, like computer vision and that all, then this is actually the route that you should take. So the recommended learning path is, of course, first of all, learn Python. The second of all is that you solve some classic machine learning examples. Now, there are also courses available for machine learning, which you can, I will be providing again the link to those resources, and you can make use of that. And then you make use of some deep learning libraries where you don't really have to do all the mathematics or the code or all of that, but it does it for you. And then again, at the end, there's some cloud technology practices, as I told before, and you can make use of that as well. So moving on. Okay, so the first question is that some people might be having, if you have started with machine learning, with deep learning, you're going to be wondering that what exactly is this part of artificial intelligence? Like this. I hope my mouse is visible. Like, what is the part of machine learning of artificial intelligence that doesn't fall in this subsection or this subsection? Well, this is not a joke. This is 100% legit. That section is just a bunch of if-else statements. Now, a lot of people here are going to be wondering that how is that possible? Is if and else statements like, is that it? Is that artificial intelligence? Is if and else statements artificial intelligence? And the answer to that is actually yes. If and else statements are a form of artificial intelligence, which is pretty mind-blowing actually. I'll actually explain this using a meme. So this is a meme that came out back in, I guess, 2014 or before. So when you look at artificial intelligence, you have on the left side, you have what people think it is. Like when you talk about AI to someone who is not studying data science or someone out of the field, they're going to be like, okay, this is something amazing. What amateur programmers think, I don't even know what this is actually. I think this is a neural network, which is super convoluted in 3D. I don't know what this is, but it's something like it seems complex. And this is what it actually is. This is a meme that actually went really famous, went viral. And it says it's just 10,000 if statements. That, like, for instance, Sophia was asked some questions. I'm really sorry that the audio wasn't playing in that video, but she was asked some questions like, for instance, how are you doing? And then she responds in certain ways. So you can actually program if statements to work that way. If there are any non-programmers here who don't know about if statements, I will provide a resource to a link to learning if and else statements as well. So you can check that out and you can learn about that too. But for now, let's just discuss how this field works, how the part of AI that is just if and else statements. Coming back, there is a sort of limitation to this approach, which is pretty obvious. First of all, the code is really, really long. Like you have to write for a robot like Sophia, you have to write like 50,000 lines of code. And 50,000 is like the minimum. You're gonna have to write more than that. And you would never reach to the level of Sophia even then. Like it's really not possible. It's just really lengthy code and really buggy code, and it doesn't really make sense to do that. Secondly, the people who have already used HackerRank would know that HackerRank code, when you execute it, it takes 2 seconds to execute a program in C or C++. And it takes about 10 seconds to execute a program of Python, like the language that I'm encouraging you guys to follow. But the problem with this kind of code, with 10,000 if-else statements, is that it's going to take like forever to execute. Like it's going to run line by line on every single if and else statement, and then by the end, well, it's going to take too much processing time, and it's just going to really clock, and it's really a pointless piece of code having that big of an AI. So what is the scope of this then? So should we just say that it's not feasible, it's something which is cool, but it's not usable, or is this just fake AI? What is this? If-else statements are actually being used in deep learning, the further component of AI, but it's being used in this way that it's combined with object-oriented programming. Again, if you don't know about object-oriented programming, that's fine. I will be providing a link to that resource as well. So they're making use of if-else statements here, and they're implementing it over here. So I've actually created this small sample code, and this sample code actually says that if road.people, this is object-oriented programming, we've made use of classes and objects, and if road.people is none, then the car will move, else the car will stop. So this is where it's being used, but again, AI is heavily being implemented in these places like road.people, car.move, car.stop. It's being used here too. But on this level, you have if and else statements. So it is being used, but again, as I have mentioned here at the complete end, that if else statements are a very limited approach to solving AI problems. Like it's really, really limited, and it cannot get much done. Like you can maybe get done with 10 lines of code or 12 lines of code, but that's it. Any more than that, you're going to have a slow, buggy program that is really not learning. And for those of you who are actually interested in mathematics and statistics, you're going to know that this is more of a deterministic sort of approach to solving AI problems. But machine learning and deep learning, they deal with more probabilistic determinations, like the probability that there's a person on the road. Because if anyone over here has actually trained some models, you're actually going to know that there's like a 99% accuracy or 98% accuracy. So we're dealing with accuracies, and that is probability basically. So this is a very, very old use of AI. This was used in the 80s maybe, or the 70s, but now it's completely died out. And if you're creating something like this, I mean, it's good for you to claim that you've made an AI classifier. Like, I will actually be giving a link to a repository where there's actually an AI classifier that's making use of basic if-else statements. But again, it's really, really limited, and this should be like considered as a baby step and not something big. So moving on to machine learning. Now, this is the part where most people that I know, they start with machine learning. And this is where actually all the fun really begins. So what I want you to do is first, I want you to look on the right side of your screen, and I want you to think for a second. You don't even need to think for it, actually. You just know by this time now that there are two animals in this picture, and you know that one of them is a dog, one of them is a cat. The animal on the right is a dog, the animal on the left is a cat. You know that, like, but the question is, how do you know that? How do you know that in this 2D picture, there's a dog and a cat? Well, the answer to that is that over time, you've seen many dogs and cats, or maybe images of dogs and cats, or maybe on your TV, maybe you own a cat, maybe you've seen it in a storybook, or maybe while learning or anywhere in other books, you've seen pictures of cats and dogs, and you were sort of told that these are cats, these are dogs. So your brain just automatically learned it. This is exactly what machine learning is. Machine learning takes data, like huge amounts of data, not even huge, like can't even be less, but it takes data. It tries to find patterns in data and tries to infer rules on their own. So if you look at pictures of cats, so you could learn that, okay, cats have whiskers. When you take pictures of dogs, you can learn that, okay, dogs have these floppy ears. Another interesting feature is that you can take heights, and you can be like, okay, cats are a lot smaller than dogs, and you have different dog breeds, cat breeds, but at the end you take data and you learn from that. That is basically machine learning. You have algorithms that take data and learn from it. And you have several applications of this, but I'll first like to talk about the workflow. The workflow is basically that you take images, like say 50 images of cats and 50 images of dogs, you extract certain features. Now, what am I calling a feature here? The feature I'm calling, say, whisker, I'm calling ear a feature, let's say height is a feature, okay? And we put them through an ML model, okay? And that model, it adjusts learnable parameters. The learnable parameters here would be, say, let's say height for now. Height is our Actually, no, this is sort of inaccurate for terminology, but I won't get into the terms and stuff like that. But I will say that we have a parameter that sets these things accordingly. So that learnable parameter will learn the values of the features by passing it through the model. And by the end of this, it will actually tell you accurately that, okay, this is a cat, this is a dog, when you give it another picture. So this is how machine learning basically works. This is a small overview. Again, this is an introductory workshop, and it's just to give you an intro on the components. We're not going to go in that much depth. So what are the applications of machine learning? Actually, I should check the questions and see if anyone has anything to ask. So just give me a second. Kingdom, queen, king is the kingdom. No. Okay, queen, goat, it should be queen, princess. Okay. Jeff Bezos now. Yeah, I'm aware. Okay. Well, I'm rooting for Elon myself because like he's into tech. I mean, Bezos is also into tech, but I don't know. It just seems nicer. Let's see. Okay. Anyways, coming back to the applications of AI, you have spam filtering and image detection. Okay, so spam filtering is basically think of it like this way: that you have big companies like say Microsoft, and you have these a bunch of emails that they're sending out, they're receiving, their employees are receiving a bunch of emails. So they've actually created software that looks at these emails, and because people are throwing these emails in spam over time because they're not useful emails, so they actually learn the wordings of the email. Like for instance, you can find a word like Nigerian prince, or you can find a word like scam, or a word like free survey, words like free survey. And after you go through all of this, you're like, okay, this is these are, your AI is learning these certain words that should not be part of an email, and then it throws the email in the spam folder. So that's how things are automatically going into spam. And these images are being, the model is being trained on the emails that the user is sending in the spam folder. So there's that. And sometimes this is annoying too, because the ML is not as efficient of smaller companies. So they actually send other stuff too. Like for instance, I remember I sent out an email of a free event, like the event is free, and just because of the word free, they actually just put the whole email in the junk folder, and I was like, okay, that's nice, that's nice. So this is a sort of a problem that happens, but okay. Another application is image detection, and I will go over that in more detail when we're discussing the differences between machine learning and deep learning. So what is deep learning? Deep learning is, well, as you all know by now, that it's a subfield of machine learning. And what it does is it solves your classic the limitations with classic machine learning. The limitations that we have, like it's not training accurately, and like it's throwing spam, it's making spam those things which shouldn't be made spam. Like just using the word free is not really enough, but it's doing that. So over there, you need deep learning to intervene. Deep learning makes use of neural networks and complex calculations. So a neural network sort of looks like this diagram I have over here. And this diagram actually, like what it does is it computes stuff and gives you a result. So more on that in a minute. So let's move forward. Okay, image classification problem. Deep learning, machine learning versus deep learning. So this is a picture of mine that I took like a bunch of weeks ago, and I'm going to use this to try to help explain the difference between machine learning and deep learning. So right now we have, okay, so what machine learning will do is that it's going to take features, like a feature is the distance between my eyes, and another feature, and same feature, distance between the eyes relative to the distance between my forehead and chin. Another feature can be face shape or structure. And it's going to train the learnable parameters to learn these features. Okay, in deep learning, what you have is you have a neural network like the one I've shown you. And what this neural network will do is it's going to slice the image up. It's not going to learn features. You're not going to tell it features like eye distance or anything like that. What you're going to do instead is that you're going to give the image as a whole. It's going to take the image and, okay, every neural network works differently. Like it processes images in a different manner, all of them. So what it's going to do is going to pre-process this image. And what my model is doing is it's breaking it down into 9 sections, and each node is taking in one section of the image. And then it's sending it to another node ahead, and then another node ahead, another node ahead. Like it's all nodes are connected in a lot of complicated ways, and it's learning the parameters. Like for instance, for example, like this is just an example about this model particularly. This is not regarding every model. Over here, it's comparing that, okay, it's seeing that hair color, for instance. Over here, it's seeing lip size, it's seeing lip shape. Over here, it's seeing nose size. Over here, it's confirming glasses, no glasses, that kind of thing. So this is the model that's actually running. Okay, I'm just going to go and see the questions again because this is a little complicated, but I'm sure that a lot of people who don't know the difference between machine learning and deep learning have gotten a good insight. I just hope I'm not going too fast. Elon wants to plant chips in brains, and guess what? Yeah, he sort of does. True. Okay, so no issues. I guess we're going to publish comment. Man is the woman. Okay, that's my comment. So, okay, again, wait a second. All right, perfect. My session is about to be over. Let me just get this done. Okay. So a little bit more on deep learning. The applications are self-driving cars, like I talked about in computer vision. You have object detection, which is, again, just like it detected which picture of me was me and which was not. That was discussed in detail in the previous slides. And another application is deep fakes, which is basically, do Google this, Google deep fakes, and you will know what that is. It's basically using a person's face, convoluting it on another actor. So this is also being used a lot. It's even used in I guess they released a model for Snapchat too, not really sure yet, but they were working on that. So the way to learn deep learning is to make use of libraries. Your libraries are Keras, PyTorch, and well, the newer model is Fast AI. So, and for that, what I recommend is that you get the Anaconda Navigator, and that navigator has like 10,000 libraries. I make use of that myself. And I'll be providing the link to actually a blog. I'll actually show you the blog too. Wait a second, sorry. Okay, so there's this blog actually. No, not this one, this blog. Okay, so there's this blog over here. It's a nice little blog. It's setting up Python environments using Anaconda. So it's gonna actually get you through downloading, installing, retrieving Anaconda, and making use of all of the libraries. So do check this out. This is also going to be a part of the resources provided at the end. Okay, sorry. Again. All right, and finally, I have also created a small deep learning repository over here, which is called Machine Learning and Deep Learning Models. Again, do check out my GitHub profile. And over here, these are actual models that work. So a lot of people who are studying deep learning have this confusion that, okay, we're studying math intensive courses, we're studying programming, and we're not actually getting to see models in action. We're not actually getting to see an actual piece of code that can take an image and tell us, is it a cat, dog, or whatnot. So you have a number of models here that you can look at, you can train, you can test, and if that works out for you, perfect. So we have this too. Coming back, we're a little short on time, so I'll just sort of hurry up. Okay, another resource I have for you guys is a number of theoretical and hands-on notebooks, and these are present in another repository, which is the AI 101 repository. So over here, you get notebooks which talk about data science. Then you have notebooks that talk about machine learning, deep learning, and so on. So this is going to give you a good insight on the components of AI. Here's an example notebook, like deep learning with PyTorch. What you do is you read the theory over here, you run the cell, you see the outputs, you learn the functions, read all of this out, and it's going to give you a good insight on the whole thing, on deep learning, on machine learning, on AI generally. Okay, coming back. So do check this out. All right, so the problem with machine learning and deep learning is that, well, we did discuss the problem with classic machine learning. Do remember the picture of mine that was being used by my machine learning model, in that it was learning certain features, but the problem is that anyone who has the same face shape or the same distance between the eyes relative to chin to forehead, they're gonna sort of like, they're gonna be recognized. So that's a big security flaw, and this kind of issue does happen in classic machine learning. It's not very good at image detection. So this can be solved with deep learning. Deep learning is deeper. It goes into more layers. There's more computation and stuff over there. Now, the problem with deep learning is that, first of all, it's GPU intensive. Now, you may have noticed that these neurons are doing a lot of calculations, and there's so many neurons here for just one picture. Like not one picture, for like one problem, like it's processing a lot of data at the same time. So a lot of computation is taking place, and this requires a strong GPU. Now, the interesting thing is that my system doesn't have a GPU. It is GPU-less. So how am I training models? So I'll talk about that. But this is a problem people have, that they don't have expensive or working machinery. So first issue is this. Second issue is that it requires a huge amounts of data for deep learning. Like if you want to teach a car how to drive, or not even a car how to drive, if you want to just teach them about, say, my deep learning model about detecting image detection, about detecting my face, I would have to supply like, I don't know, like 500 pictures. Or if less than that, I would at least have to supply like 60, 70, 80 pictures. And those, even they have to be like in a specific format, or I have to write a piece of code that formats it for me. So that's a lot of data. And for especially stuff that a lot of research is not being done on, like a lot of stuff, like for instance, we don't have a lot of patient data when it comes to some healthcare fields. So for that, we don't have the data. So what are we going to do over there for deep learning? How are we going to create a model without data? Another issue we have with deep learning is that it has very complicated code. Like it's not easy to program something to look like this. I mean, imagine writing this in code. It's difficult. You'll see that with the deep learning models too, that it's not an easy code. So this is another problem we have with machine learning and deep learning. So your solution to this problem is cloud technologies. Cloud technologies including Microsoft Azure. Microsoft Azure provides VMs, virtual machines. Virtual machines are basically servers, and they do computation for you. Azure provides cloud storage. They provide open data sets. They support drag and drop. The drag and drop I talked about in the beginning, they even support that. So you can make use of that too. And you don't even need to code anything. You can just drag and drop models. So that makes it really easy. Now, I know a lot of people are thinking here is that, okay, this is all good, but this is a paid service and it costs a lot. Like, how are we going to pay for that? And for you guys, there are exclusive offers. You have free $100 worth of credits if you get the GitHub Student Developer Pack, and you get free $200 worth of credits if you sign up on Microsoft Azure right now. So this is available. You can make use of $200 worth of credits to train models, to do whatever you want, or just explore the cloud, anything you really want. And now a lot of people are thinking that, okay, this is good, but what is the worth of these $200 worth of credit? How much can you actually get done with this? The answer is, okay, the answer to this is that I actually have my account open here. And this is, I'm a Microsoft Learn Student Ambassador, as I told before, and I get like $150 worth of credit every month. So I trained two models, actually, one for machine learning, one for deep learning, and I pretty much got done with Azure. I actually even got passed the certification exam for that very easily, just by tinkering around using my free credits. And as you can see, with only 0.64 US dollars, I was able to do all of this. So this is all it takes, really. So with $200, you can do a lot, like a lot. It's not going to take you much to get this done. So do try that, do try this out. It's really going to help you accelerate your deep learning models. And this is basically the future of artificial intelligence. Okay, so moving on. I will tell you that this is like the end almost. I will tell you to do check out the blog post there was another event that I was actually hosting before this event a few weeks ago. It was called Introduction to Artificial Intelligence. Now, the sessions are good, but sessions are not like, sure, you will get the recording and all of that, but they're not good in terms of this, that, well, I mean, it's not really a lot of written content. So with the help of this blog, it actually covers everything. Like, let me just show you. Where is it? Okay. No. All right, yeah, here it is. So this post, it covers AI, the components, learning resources, a lot of things that I discussed here, just in more detail, and you can look at them at your leisure whenever you want. And it even has you can build your first AI classifier hands-on over here, and includes a lot of other stuff. So I will put that in the resources link. Do check this out too. So coming back, there's this. Okay, and now we also have a developers community. It's a Discord channel basically, where we have a lot of people who are interested in artificial intelligence that communicate with each other, and they discuss AI problems, and you have events posted there. I'm sure a lot of people over here are from the Discord community too. So that's really nice, and do check it out, do join here. I will put the link in the resources too. So thank you. That's all from my side, and I did take about 40 minutes, so that's good. I'm gonna now open the questions, and I would love to take them. Just 5 minutes for that, and then we can get to Huzayfa's part. So you are so smart. Thanks for your advising. Well, thank you so much for your generous comment. Will we get the recording? Yes, you will get the recording of the session. It will be available on the Discord channel. My moderator friend will put a link over there we'll publish a link for that. Yeah, here you go. So you can just read that over here. Okay, so here it is, the developer community, just join it. I'll put the recording over there. And check out the blog, check out other stuff too. And I also will put my GitHub link here too for you guys to view. So that's it from my side. Let me just check one more time in the comment. Okay, that's it. Now I'd like to introduce Huzayfa, who's going to tell you about the very doable practical applications of this field.
Thank you, Mr. Muiz, for your exclusive and precise talks about AI and machine learning. I was just so happy to hear that, because it's also helped my speech to understand better for the participants and the ones that are starting here. My name is Huzayfa Nasih. I am from Iraq, the first Iraqi MLSA student, and I am also the co-founder and lead of Algotech, which is an online e-learning community. My talk is just about intelligent architectures for intelligent machine. So what we mean by intelligent architectures for intelligent machine? Intelligent, as Mr. Muiz talk about intelligent architectures, about AI, intelligent artificials. So the problem with intelligent artificials is that we need an intelligent architectures that help our architectures, our hardwares to be intelligent. So I asked Mr. Muiz to stop sharing his screen to share mine. And okay. What we mean by intelligent architecture for intelligent machine. Firstly, before starting anything, I just want to go through the parts of our computer hardware. Firstly, we know everything. We know that our computation machine, we just not talk about PCs, but about computation machine, PCs, mobile devices, server, everything that do computation for us. We have what? We have computation, which is done by processor, and we have communication, which we mean by input and output devices, and also we have a storage, a memory to store our data. We all know if we have a CD, we insert that CD drive to our computer, for example, so the CD is input of our computer. So the things that are included in the CD is the output that we get through the CD. And the whole process just go through processor, that everything is just have no meaning except when it goes through processors. But our talk about what about main and internal memory, because we know that more than 98 of our data are stored in memory, servers, clouds, and even we just go through a new technology, new era for decentralizing internet, which they talk about fog instead of clouds. So every data included in our main or internal memory. So when we want to do a work or process something, for example, I want to just show my screen for you. When I show my screen, we know the things that we have in our memory. For example, this PowerPoint is based upon in my memory. In memory of my computer. So the data go through processor, and processor process what we want, and after that it sends to output, or it sends back to the memory. So the whole computer system works like that. But in this talk, we demonstrate that this design or this philosophy we are using in computers not intelligent enough for the coming of artificial intelligence. So we want to what? We want to advance our architectures, our computer hardwares to be more intelligent for tasks that we do nowadays, especially that Mr. Muiz talks about what? About machine learning and AI. All machine learning and AI based upon what? Upon data. Just not AI and machine learning. All computing is bottlenecked by data. We have no computing, we have no process, and we have nothing if we have no data. So we should know that the main point is data, not something else. And after that, data is a key for machine learning, artificial intelligence, genomics. All important workloads we have that are all data intensive. All machine important workloads we have, they are all data intensive, and they need a rapid and efficient process of large amount of data. The data we have, they need a rapid process. We talk later that the most of our process time just waiting for the data come through around. But we need what? We need a rapid and efficient processing, because we need more performance. And we know the data is increasing every day, every millisecond. Data is increasing because they are just not humans. The human data are increasing. We have a lot of machine learning devices that do machine learning, AI devices. So every second, even nanoseconds, they are learning and their data is increasing. So we should think about data, nothing else. We have data key for future workloads. Data is based upon data, pre-processing, AI, machine learning, and even data analytics, in memory data analytics, and even clouds, fogs, edge computing. Everything is what is based upon data. And data is based upon performance and edge energy bottleneck. So the data we want, so we need a high performance, and we need an energy sufficient or energy efficient data or process. So when we say our architectures improve it, when we increase performance by decreasing energy. So it's not important to increase performance by increasing energy. So they are inversely proportional. We should be aware of that. When our systems, we say that our systems gets advanced or improved, that the time that we increase it performance by decreasing energy. Unfortunately, today's architecture is reverse. So data is key for future workloads. What you see is that sequencing of DNA. We all know what's DNA. DNA is just like base of our computer. As all humans based upon DNA, and we can characterize everything of humans by their DNAs. So it's important to sequence DNA. We sequence DNA by for example, we have this lever, and this lever we extract DNA by some machines, some intelligent machine, and after that we prepare a library for them, and at last it goes through what it goes through advanced and we go through an advanced and also just powerful machine which sequencing our DNAs. This machine is based up, it's just a computation machine that is sequencing our DNAs and reads the sequence of the DNA. In 2014, by this machine, we be able to just read 229,000 sequence. We just able to read that amount of
Okay, I think that Huzaifa had an internet issue. So please do stick around for a while. I'll see what I can do on his end, and just wait for a while, okay? So I'll try to get him back. Till then, do feel free to ask any questions, and do check out the resources with the link provided. And if you have any questions regarding the resources or how to do them or what to do, then do ask in the questions while I get this issue fixed. And don't worry, it's just going to take like around 5 to 10 minutes. It's not a really big issue.
Sorry for the interruption. That was a problem with my internet connection. So we talked about in this in 2017, we just could read 1,620,000 of DNA sequence, and nowadays we able to read more than. What's just important of reading DNA sequence? The importance of reading DNA sequence, as much as we can read more sequence, we can know about more about the disease, about bacteria, about virus, and we can find true medicine for them. So data overwhelms modern machines, and we know data computers have storage and memory capability and communication capability. We said input and output, and also computation capability. This is what we need in a computation machine, which we talk about. So greatly impacts robustness, energy, performance, and cost. What greatly impacts an architecture or this three functions of a computation machine is that energy, performance, cost, and robustness. We don't have a good architecture if it consumes a lot of energy, or its performance is just so low, or its cost is so high. So we need what? We need a computer or a computation machine has a great robustness and energy sufficient and high performance with a low cost. How we can achieve that? We talked about that. Our computation system is like that. We have computation in the center of everything. Every data we need to store, to input, to output, to store, or just to process should go to processor, and after that go to other components. So process is the center of our architecture. This is the architecture of a computer. Now we have the architecture of a computer. Now we have. As you see, there are a lot of problems that we have with what with our architecture, because as you see, there's core 1, core 2, 3 till core 9. Every computation of our computer architectures are done in this course. So the other components that you see is just about what? About moving data. So most of the system now we have is just to store or move data. So the problem is that we say this is a computation machine, but when we look at this, most of the architecture is just designed to store or move data, and our architectures now we have is a process-centric architecture, not a data-centric architecture. So after that, this is research that done upon Google workloads, Google devices. It shows that 62.7 of the total system energy of a device is spent on just data movement. We say we have a computation machine, and this machine or this device should do computation for us. But we say see that the most of our energy is spent on the data movement. So what's our point? What's our goal? We should create an intelligent architecture to handle data well. So we need an architecture to handle data well. So we need, and we don't need a process-centric architecture. This is perils of process-centric architecture. We see that we have an imbalanced system. Why? Because the process is just done in only one place. The other place just for what? For moving data. So it's energy inefficient. It's like we have, for example, water in my room. If I have water in my room, it doesn't need much energy to get it. But if I don't have water in my room, I should go to another room to get water. So I need more energy. It's a bit complex, and also performance is low. And after that, it's complex and bloated processor, and also it's energy inefficient, low performance and complex. And remember that we said a good architecture should be energy efficient, high performance, and simple. So how can we handle data well? We say our point is to create an architecture that handles data well. We must be ensured that data does not overwhelm the components. The data we have does not overwhelm the components that we have. How can we achieve this? Via intelligent algorithms. So this is about artificial intelligence, machine learning, and programmers. And also we need an intelligent architecture. So we need an intelligent hardware of devices, of computation devices, to ensure that are not overwhelmed by its components. So we create a system. So the intelligent algorithms and intelligent architecture should be compatible. So we should create a whole system design that algorithm and architecture devices. So, and also we need what? Take advantage of the vast amount of data and metadata we have. So the problem nowadays is that we have a lot of data, for example, in cache, in registers, in processors, even in RAMs, but we cannot get even a benefit from these data. For example, you are a graphic designer, and if you every day you just use your Photoshop, Adobe Photoshop, and we know that Control Z is one of the commands that we use very often. So every day we use our Photoshop and we use this command, but even though that registers, cache, memory, RAM does not take advantage of that data to use to improve the architecture. So we should what? We should take advantage of the amount of data and metadata that we have. So how can we achieve that? We achieve that by improving architectures and system level decisions, by creating intelligent memory controllers. And after that, we need to understand exploit properties of different data. We have different data go through our RAMs, our processors, our caches. So we should have what? We should have a good architecture that exploit the properties of that different data to improve our algorithms and architectures in various metrics. So architectures of today, they are terrible at dealing with data. We said architectures that nowadays we have, they are all terrible with dealing with data. Why? Because they designed it mainly to store and move data. They haven't designed it to compute data. So it's a problem. And also they are process-centric and not a data-centric. The whole system we can't even run a simple command without processor, and even it does not boot without a processor. So it's a process-centric, not a data-centric, but the main point is data, but unfortunately it's a process-centric. And architectures we nowadays have, they are terrible in taking advantage of mass amount of data, as we said. So the problem is that they are human-driven decisions, not data-driven decisions. So we have designed this architecture, and this architecture simply we can say, in another word, it's dumb. It cannot just improve itself. It cannot go beyond the decisions that the architecture or the engineer designed it for. So we should create a data-driven decision. And also they are terrible at knowing and exploiting different properties of the application of data. We have different data. So for improving our architecture, we kind of need to characterize our data, and we create an architecture which is data aware. The main point we need, and the thing that can solve a little bit of our problem, is data-centric or memory-centric architecture. Why we say memory-centric? Because we have no data when we have no memory. So when we are saying data-centric, we mean by memory-centric architecture. So how can we achieve a memory-centric or data-centric architecture? The first thing which we go a little bit in detail is that process data where it resides, where it belongs, where it makes sense. We should process data where it belongs. We have memory, and we have a lot of data in memory, for example, in ROM, in RAM. So we should process data in them, not in processor, or process in a near memory structure, not go through cache, register, processors, control units. This takes a lot of energy. And we should have a low latency and low energy data access. The architecture we have a high latency and high energy data access, because we have a lot of components. For data to be processed should go through this component, so it needs time, so the latency is high, and also needs energy to go through these points. And we need a low-cost data storage and processing by high capacity memory at low cost, hybrid memory and data compressions. And we also need an intelligent data management. As we said, we need our architectures. They are terrible. They are not data aware. They cannot characterize data, or they cannot take benefit from the vast amount of data they have. So we should create an intelligent data management and intelligent algorithms to characterize our data and take benefit from them. So how we process data where it belongs? And first, this is not a new thing. This is a new methodology, a new theory, a new prediction. This man, Harlow Stone, published a 3-page paper, A Logic in Memory Computer, and it talks about we should compute in memory, not in processor. We need processor in the architecture we are talking about now. We need processor, but we must create an architecture which the memory is not just kind of dump, should make some process. So why we talk about memory computation today? Why it's a hot topic today? Because we have some push from technology. For example, we have the DRAM scaling at Geopadry. So DRAM scaling is one of the problems that nowadays we are facing. If you have time, you can go to Throw Zero project and you see what does DRAM scaling face problems that we are facing today. So we have also in today's architecture, we have controllers close to DRAM, which we can take a benefit from them. And the industries we have that are providing DRAMs for us, they are open to new memory architectures. And also we have a pull from systems and applications. We have a pull from system and application. Data access is a major system and application bottleneck. The data access we have now, so they are a major system and application bottleneck. We all know that, and systems are energy limited, so we cannot give a lot of energy to our system. And we said that a good architecture should decrease the amount of energy and have an energy efficient. So if we increase the power today, increase the power of our computers, we should increase that energy. So our energy is limited. We cannot go beyond the limitation of energy. So we need a kind of architecture which is energy efficient. And data movement much more energy hungry than computation. So the system we are talking about now, the architecture we have now, the computation machines we have now, we know that they are data movement hunger, not a computation. They are just about data moving. As I showed the picture, when we look at the most of the components is about storing and moving data. Just we have little small components that is just about processing data. So we should hungry about processing data, not about moving data. But unfortunately, the systems we have today, they are data movement hunger. And if you see these two kind of pictures, this is 3D stack DRAM we have now. There's a base layer. This our kind of architecture let us to create a computation in memory. Challenge and opportunity for future. We need a high performance, energy efficient, and sustainability in architectures. The problem that facing today in today's architecture now is processing of data is performance far away from the data. The processing of data we have is just far away from the data itself. So as we talked about, the data are process centric. All data are in processor at a great system cost. When we want to process even a single simple data, we need go to through a processor, and we talk about the improvement if we make process in main memory. And processors heavily optimized and consider is the matter. Data storage units are dump. Yes, the memory and main memory we have is dump. We can take a look at this graph. You see that most of the time processor is what just waits for the data to come from DRAM. So the processor we have now, if we decrease it to 50% the power of the processors today we have, so we have no worry about it slowing our computer, because the most time we lose about 55% of our time is processor just lose about 55% of times waiting for data. And Richard Size published a paper, just one single page paper in 1996, and he at last say, I expect that over the coming decade, memory subsystem design will be the only important design issue for microprocessors. So the only issue we have, as he says, is that we should improve the architecture of our memories, because we are good about processors. And this about Google data center workloads. As you see, the part in it's just a Google Ad, Big Table, Disk, Flyster, Gmail, and this is Google data centers. The part is just inside the square. You need the time that processor waited for the data, and you see how it's just a great time we are wasting in the architectures now we have. Energy waste in mobile devices, 62.7. The total system energy is spent on data movements, not just about latency, about performance, about cost, also about energy. And we said energy is limited. So it's a great deal that 62.7 of the energy we have in mobile devices is just spent on the moving of data. What we want process inside memory. Our main point is just processing inside memory. And what's our point? How we can do that? We can use processor just to send queries, not send data or receive data. Send queries to memory, and also memory sends the result to the processor. And we will talk about an example how we can achieve that. We have many questions for this kind of architecture, and we need many improvements. The questions, some of them just have no answer to now. We need a compute capable memory and controller processor chip in memory units, software and hardware interfaces, systems, software, compilers, language, and also algorithm and theoretical foundations. The part we need to improve is all from algorithm to devices. We need to improve this part. It's a big deal for gaining processing inside memory, and we need that. So we need from programmers till the people that working with just small transistors, we need them to improve the system we want. Processing inside memory have to approach minimally changing memory chips. We can just make a minimal change in memory chips, or we can exploiting 3D stacked memory, as we showed earlier. This is 3D stacked memory. We don't talk about it today because it just needs a lot of time, and also it's a bit complicated. But simply we talk about how to minimally change the memory chips. We just use an example, and before the example is just about data copying of data. We talk about copying of data with the previous architecture, with the architecture we use now, and with the architecture we are talking about, the architecture should be improved. Google claims that 5% cycle in Google data center is just 5% of its command is just mem copy and mem move. It's just about copying and moving data. So it's a good, it's just a lot of data, a lot of times, a lot of energy. So we talk about how simply we can get that. So this just DRAM cell orientation is not just so much important. Today's system for a data copy, a bulk data copy. Firstly, we have data in memory. So the data in memory should go through memory controller, level 3 cache, level 2, level 1, and to processor. And after that, it comes back. We have high latency, high bandwidth, and also we have cache pollution, and also unwanted data movement sometimes because caches have some algorithms to take data. So sometimes we just send unwanted data. And also for this simple, for just 4 kilobyte page copy via just the systems, today's architecture, we use 1046 nanosecond and 3.6 picojoule. But we can do this with the future system we are talking about now. Same problem. If we change that, the idea is that just creating or moving or processing data in memory, we can change 1046 nanosecond to just 19 nanosecond and 0.04 picojoule. So it's just a great amount of energy and also latency. So we improved latency, and we decreased latency, and also we decreased energy. So our system is just sufficient and sustainable. The idea is that first time in step 1, we activate the row in memory we want, and we send that row to row buffer. We just said we use 4 kilobytes, and after that, in step 2, we activate the rows that we want to copy the row 1, row A data, and after that it goes through that, and a row buffer will be empty, and we will gain a lot of energy and we improve our latency. So you see this picture. Memory should work as an accelerator. If we cannot compute inside memory, we will go to through this kind of architectures which is not energy sufficient, and we have a lot high latency, and we have a lot of problems with our architectures. And also we can do some memory bulk bitwise operations. We can just in memory we have now with just a simple amount of editing, we can use what copy 0 and or an MAG at a low cost. We use the theory and algorithms that we see now. Bitwise bulk operations, we use bit waving for database queries is just important. Bit index for database indexing, bit funnel, DNA squeeze mapping. We can use just this DRAM with a little bit editing. We have some pros and some cons. The pros is only small change to the DRAM we have, and we provide a significant improvement, and as we showed, in energy and latency. And the cons are we need to identify a program regions and convert them not applicable to all workloads. So we need to change the architecture and the algorithms of the programs and the environment. Data in DRAM is lost in input rows needed to properly map data. We may have some lost in input rows of DRAM, so we need a properly mapping data. So we need an intelligent algorithm, and data depend on the analog properties of the cell. So we need to consider a variation in cells and also remapping our data. Challenging an opportunity for our future. We should computing architecture, the computer architecture we have now with a minimal data movement. We should decrease the data movement to achieve high performance. Architectures today, we said, they are terrible at taking advantage of vast amount of data and metadata available to them. So what we can do for that? We just fastly go through these pointers because just too a bit complex, and also we don't have enough time for that. We should explore data to design intelligent architectures. Architectures we have now is human-driven, human designs, the policies, how to do architectures work. We said they have no mind, they are dumb, they cannot think, they cannot improve. We have two simple, short-sighted policies all over the system, not automated, data-driven policy learning. So the architectures, they are not data-driven, and they cannot learn anything. Almost no learning can to take lesson from past action. We have no learning. The actions that just cache, memory, processor did, they have no learning. They cannot use that data they used it before. So can we design a fundamentally intelligent architecture from fundamental intelligent architecture? So the intelligent architecture we want to create for getting benefit from metadata we should have a data-driven architecture. Machines, the architecture we have, they should learn the best policies. They should learn what's the best for them. As we said for Photoshop, the architecture, for example, cache, when we open Photoshop, it should know that one of the commands I always need is Control-Z, Control-S, Control-D. So if the architecture we have learns from its past, so the data movement will decrease. And also we need a sophisticated workload-driven changing far-sighted policy, and also automatic data-driven policy learning. We need some kind of machine learning models to make the architectures data driven. All controllers are intelligent data driven agents. The controllers, memory controllers we have, so all of them should intelligent and data should be intelligent and data driven agents. So how we can start this kind of architecture? The thing we need is self-optimizing memory controls. The memory controls we have is like that: memory, and we have memory controller and processor. How to schedule requests to minimize system performance. Memory controllers, it works as resolving memory contentions by scheduling some requests. But we have a problem with memory controller, making it intelligent or creating. The problem is that the controller we create need to obey DRAM timing constraints for correctness. There are many timing constraints. We have a lot of timing problem. And also we need to keep track for many resources to prevent conflicts. We need to keep track of many resources. We need a lot of resources to just keep track of not losing or making conflicts between data. We need to handle that DRAM refresh. One of the problems we face in DRAM is DRAM refresh. DRAM refreshes a lot, so we should handle DRAM refresh when we create a memory controller. We need to manage power consumptions, and also because needs also energy, and we need to optimize performance by creating a memory controller. But this picture that shows about timing problems in memory controllers we have. Reality now we have, it's difficult to design a policy that maximizes performance and energy efficiency. Why? Because there's too many things that we should think about, and continuously changing workloads and system behavior. The behavior we have now, they're continuously changing. The data we have now continuously changing. This is the reality we have. But what we are not just dreaming, what we are working on it is it would be nice if the DRAM controller automatically find a good scheduling policy on its own. So we does not just bring processing to DRAM. We bring what? Controlling and also scheduling to DRAM. So we don't need. We say we should make an architecture. We don't need memory controller. If we need, we should create a highly intelligent memory controller. And as we said, it's too difficult even to create a one, not just highly efficient or highly intelligent. So we can what? We can bring memory scheduling to DRAM. And the problem, self-optimizing DRAM, the problem is that DRAM controls are difficult to design, as we said. The idea is a memory controller that adapts its scheduling policy to workload behavior and system conditions using machine learning. As we said, using machine learning models to differentiate and to get benefit from data set. The observation is reinforcement learning maps nicely to memory controller, bringing highly intelligent algorithms to memory controls we have. And also we should design a memory controller as a reinforcement learning agent. We should design a memory controller that's just a learning agent. And also we should design this memory controller in the DRAM. And memory controllers just work like that. We want it's just based on DRAM. The points we have some reward function, state attributes, and some actions. We have +1 for scheduling read and write commands, and 0 at all other times. The scheduling for reading and write in memory controllers we indicate 0 +1, and we indicate 0 at all other times. So the goal is to maximize long-term data bus utilization. And also we have some state attributes. We have number of reads, writes, and load methods that we should care about, number of pending writes, and also we have a request related. And we have some actions we should consider about when we design or when we create a memory control, activating, write some commands and actions. Read and load means, read and store means, or pre-charge, permittive, and NOP. And finally, we say architectures are terrible at differentiating the data. They are not data aware. So simply, a data-aware architecture is understand what it can do with and each piece of data. Every day we have a lot of various data. So an intelligent architecture should understand the behaviors, the characteristics of that data and behave like it should behave. And it makes use of different properties of data to improve performance, efficiency, and other metrics. We need compressibility, approximability, locality, sparsity, critically for computation and exact semantics. We have just highly intelligent algorithms for each this kind of behavior we should need in a data-aware system. But it's just too complicated and not necessary for this talk. So, as we said, we have different data, but the architecture we know we have is just not dealing the data as should be dealing with. So there's the problem of architectures today we have. So finally, a short summary, our architecture, we said we have a terrible, we have not good architecture for AI and artificial intelligence and the coming future for computation machine. We call them, they are computation machine, but what we see in them, they are not about computing, they are about moving data. So this is a problem. And we said, we should create an architecture that we care about computing data, not about moving data. And we know that our architectures are terrible at dealing with data. They are designed mainly to store and move data, not to computing data. They are process-centric. They are not data-centric. So we said we should make them data-centric, and they are terrible of taking advantage of vast amount of data. So we should improve them, and we should bring some highly intelligent algorithms to the table to get this kind of function to our architectures. And our architecture are terrible at knowing and exploiting different properties of the application. And thank you. This was all for my speech. You can contact me, or you can find everything about me in my portfolio website, www.szkurdi.com. Thank you for your time, and you can have we can have your questions. If you have any question, you can ask. So I think we have no questions. So thank you for being here. I have nothing left, and I asked Mr. Alvi if he have anything left to say. Mr. Muiz?
No, nothing from my side. Just thank you so much for having me for this session. It was really good, and I really hope that people benefited from there. I did read the comments, and a lot of people enjoyed my session. They enjoyed your session too. So I guess we're in the right direction here. So that's it. Again, thank you for having me for this session.
Thank you for being here, for your talks, for your exclusive talks and precious talks. And I hope this meeting and this event was fruitful for all of you. And at last, also thank Mr. Muiz Alvi for presenting here. It was a good event and good to have him here. So thank you for all of you. We have nothing left, and bye.